Hello, everyone. Welcome to the July 2014 Network Plus Study Group live from the headquarters of Messer Studios in Tallahassee, Florida. My name is James Messer, and I'll be your host for the next hour and then some as we go through some of the questions you've sent me during the month, and we'll talk about all things networking. I want to appreciate you, send my appreciation to you for joining us today. There's a lot to go through in a very short period of time, but I wouldn't be able to do this without your support throughout the month, for visiting the website, for watching the videos. There's so much going on the Messer Studios right now. I wish I could tell you. There's a lot of activity. There's a lot of things you don't even see here on the other side of the camera, but over the next few months or so, there's quite a bit we're working on. So hopefully that is something that will slowly be able to trickle out and tell you about. And we wouldn't be able to do these things without your support. We also want to thank the folks who have purchased our downloadable and offline version of our Network Plus course. And if you want to see more about that, you can see it at professormesser.com/download-network plus. If you'd like to follow what we're doing, you can follow us on Twitter at professormesser.com/Twitter. And perhaps even more important, if you wanted to contribute in some way to the site, you could always subscribe to our YouTube channel. That if there was one thing you had to choose from and you didn't want to buy anything or you didn't have money to contribute, that's absolutely fine. But joining or subscribing to the YouTube channel goes an amazingly long way. And I want to appreciate everyone who's done that so far. I think we're up to 77,000 subscribers. Trying to get over that 100,000 mark so that we get some nice things from Google. We'll see if that really happens. I'm changing up the format a little bit this month. If you're watching this live on YouTube right now, there is a live chat for this that you could find at the Professor Messer website. At the bottom of every page on the Professor Messer website is a chat. It's there 24/7, whether I'm streaming or not. There's always somebody in there. I'm usually lurking around there somewhere. There's a chat also that I opened up just for this live Network Plus study group chat, and you can follow along with what we're doing there. So if you happen to be watching this on a different website and you're trying to figure out how is he communicating and how is he getting information, that's where I'm getting it from. There is also some live interactions that I like to do during the study group. In the entire first hour of this study group is going to be all about questions and answers. I'm going to be asking you some pop quiz questions and you're going to be answering them. So I've got a bunch of questions lined up. So this will be fun. But to participate, you need to go to the Socrative website. Go to socrative.com, SOCRATIVE.com, and it will ask you for a room name. You can either put your name in or just put any name in when it asks you for a name, and you can put in room name Professor Messer. And you just click on that student login link and use the room name Professor Messer. There's also an app for Socrative. So if you don't want to pop open a separate window and you'd like to do this in an app that just is going to give you one question after the other, you don't even have to change web pages anymore. This is so great. You can download that on Google Play, the iTunes App Store, or even a Windows app. These Socrative folks have thought of everything. And it's kind of nice to have this capability available so we can do those things. I'm going to start this right now. I'm going to turn and randomize and turn some things off and that sort of thing. And let's now start this. In fact, I'm going to turn on student feedback just for fun. So I'm going to start the presentation on my side, and you're going to see things pop up in that testing area. So as I start these messages, you will see things pop up. And the first question I have for you is just how to study. How long have you been studying for this Network Plus certification? There's a lot of different options available for Network Plus, a lot of things that you have to learn, a lot of objectives you have to go through. I would imagine usually it takes someone 3 to 6 months to study some of these topics. If you know networking, it will probably work a little bit faster than that. And you get to answer now how we do. In fact, I'll bring up on my screen so you can see how we're voting. And you can see that we have less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, over a year, or I already have my Network Plus certification, thanks to M.A. Graham, who reminded me to put that in there. And in fact, 17% of you already have your Network Plus and you're attending. And of course, you can get continuing education credits for this. I'll talk more about that as we go through the presentation today. but I've got a lot of questions. So you're going to be going right back to the same page. You don't even have to change your browser. You don't have to change your app. You don't have to go to a different URL. I'll just simply be hitting these questions over and over right here in the same place. Very easy to follow along with what we're doing. Less than 3 months, 59% of you who are watching right now, less than 3 months studying. So that 3 to 6 month time frame, I think that's the sweet spot for the Network Plus. Of course, if you're like me, you get through month 3 or so, and then something happens and you end up having to do something else, and you come back after over a year. I'm one of these 13% down here who come back after a year or so. Oh yeah, I need to finish up what I started. Eventually I will get there, and that's pretty important. So I'm going to go through a lot of the things that you sent me. A lot of the questions that I created today, by the way, came directly from you. When you register for this, I send you to a site where you get an email that notifies, yes, we're doing this right now. But one of the things that I find really useful is that I'm able to take those questions and turn them into pop quiz questions, and that's what we're going to do today. A number of the questions that I got are about the Network Plus certification. And they're absolutely about this particular thing. The current Network Plus certification is called the N10005. If you have a book, if you have study materials, if you see things on the internet to look at, and you're trying to study for this particular version, which is the latest version and the only version of the Network Plus exam currently, all of your materials should say that these have been written for the N10005. Now, the N10005 was released on December the 1st, 2011. And for those of you that have followed along through the years and you've looked at some of the other CompTIA certifications, they tend to update these things about every 3 years. So I'm certainly thinking somewhere near the end of this year, beginning of next, we will probably see a new version of the Network Plus exam. If they do like they've done in the past, it'll be the N10006. I guess they could call it whatever they'd like. That's what I would expect it would be called. So right now, if you think about that, you've got about 6 months that you've got before the exam changes, but you actually have longer than that, because when they change the exam version, they also give you time where both exams could be taken. That would be horrible if you were studying for the exam, you're ready to take it, and suddenly it changed to a new version with new objectives and new information you had to know. They don't do that to you. So they give you a long time frame, usually about 6 months or so. So you could have at least a year right now before that exam, the N10005, went away and was retired. And at that point, you would have to take the N10006 or whatever that next version is going to be. This version has new things like virtual networking. There's some additional OSI emphasis in this exam. There's quite a bit more security that was added to the N10005. So if you try to study with the older N10004 materials, you're not going to have some of the new things that were added here. One of the advantages of network, though, is that the networking technologies do not change dramatically, or at least not as dramatically as something like an operating system might be. You know, we're talking about Ethernet, and we're talking about copper cabling in this exam. Those are technologies that have been around for a very long time, and they continue to be used very popularly in all of our businesses, our organizations. So this isn't like this isn't like some of the older technologies and operating systems. If we went back to operating systems that came out when copper cabling came out, we'd be all studying DOS and other operating systems, the old Novell NetWare, the Banyan Vines for networking. Fortunately, we don't have to study all of those. But what you'll find is there will be smaller incremental changes. So don't worry too much. Even if you get close to the exam changing, don't worry about it being a dramatic difference. It won't be. It will be an incremental difference. There will be some new technologies on the new exam. They sometimes get rid of a number of old technologies as well that aren't used quite as much, but that should help answer a number of the questions that I got this month. Before we get into the questions, let me also remind you, if you're ready to take your exam, you've gone through all of my videos, and you just wish you had taken every bit of all of the graphics and all of the text from every single video, and you had it in one place, I've created this for you. It is my Network Plus study guide. This study guide is a PDF document. It's immediately downloadable. It's something that is digitally there and available for you immediately. And I've taken everything from every presentation that I do in every video. So if you wanted pictures of cable types, pictures of fiber connectors, if you wanted to know the text from all of the different security section of the exam, it's all in here. So everything is in there, 11 pages in this PDF document, and it's $10. It goes to help what we do with the site. One great thing about the Professor Messer site being so popular is that we have a lot of people visiting and watching the videos, but it does take a lot of money. We're over $1,000 a month to do the hosting on the website, and every single bit of this goes back to support. And I want to thank everybody for supporting us with the purchase of those study guides throughout the month. I can't tell you enough how much that really helps what we're doing. Okay, it's time for questions. Let's see how much you know. Let's see, we're going to start with an interesting kind of a security question, but it is a lot about networking and it's a lot about file transfer protocols. And the question is more of a true or false question. Let's do it. Let's see, go to the next question here. I'll click the next button. So this is a question that asks on an FTP bounce attack. Okay, true or false? An FTP bounce attack works by directing or bouncing a transfer to a port number on a third device. Is that how it works? Is that what a bounce attack is? Where you can answer true or false. I'm trying a true or false question right off the bat. This is a new format for the Socrative application because it tells you immediately the feedback of how you did. I try not to do too many true or false ones there, but this topic is one that's very specific. There is a specific section of the Network Plus requirements that talks about an FTP bounce attack. So you have to know what the bounce attack is, or at least understand what people are doing with that bounce attack. And so I wanted to provide at least a place where we could start typing in what that bounce attack is, or at least get an understanding of what those things are. Or you can tell me, yeah, I know what a bounce attack is. Or you might say, I'm not quite so sure. And once we figure out what people think about the bounce attack, then I'm going to show you what the bounce attack is. Again, you can go to the Socrative.com website or use the Socrative student app on your Google Play, your iTunes, your Apple's iTunes store. You can go to the Windows Store and download the app. So it's some good information to have to know these bounce attacks. There's a whole section of the Network Plus certification that talks about different kinds of attacks. And these are very important to know because you will get good examples, the monthly updates from Microsoft. And those monthly updates will say this particular vulnerability that you need to patch has a buffer overflow, or it has a command execution, or command, those types of things, especially remote command execution. Those types of attacks and security pieces you'll get into in great depth in the Security Plus exam, but you still need to understand a number of them for the Network Plus exam. Let's see how we did on this particular answer. The question is, an FTP bounce attack works. See if I can make this a little bigger so we can read it. By directing or bouncing a transfer to a port number on a third device, 62% of you said absolutely true. 38% said, nuh-uh, not the case, not buying it. That is not what that thing is. So what is this bounce attack, and why would someone use this? First, you should know that an FTP bounce attack is a relatively unusual thing to find these days. This was a vulnerability in some very early versions of FTP. Most FTP servers, the software that you would run on a device, that software generally does not allow an FTP bounce attack any longer because it was such a well-known way to redirect traffic somewhere else. The way an FTP works is it's sending information. You as the source, you're logged into the FTP server. That's the device in the middle. And when you send information to this server, you're telling it to, here's a command, and here's where I would like you to send the results of that command. And in fact, you could see there's a port, and it gives you this 192.168.0.5, port 135, and you're telling it to go run the list command and give me the answer to the list command on 192.168.0.5 on port 135. But wait, I'm on 192.168.0.8. Why am I'm telling the FTP server not to send the answer to me, to send the answer somewhere else. And that is the bouncing. I should not be able to do that, because what people would do was send information to that port 135 over on that device, and see if that device responds on that port number. It's almost like running a port scan like you would do with Nmap, but you're running the port scan using a third party and you're using it from an FTP server. So this allowed some of the bad guys. This is more of a recon. So in the chat room, somebody's saying, is this brute forcing? Are you trying to get into the other machine? You're not. You're really just doing reconnaissance. You're really just trying to find a way to communicate to that device. In extreme circumstances, you could also send malicious software or something malicious. If there was a vulnerability on the .5, you could send it via the FTP server. That would be a very specific instance of this and very difficult to do. It's most often used for something like a port scan or to do reconnaissance of those devices. So for those of you that answered yes, this is a redirection, a bouncing of a transfer or information to a port number on a third device, you would be absolutely correct. Give yourself a bell, something. Give yourself a gold star. Count 1 on that piece. So let's change our direction then. Let's do another question for us and go to question number 2. And I'll click the next button on my Socrative. So you will see this also. In which of these cases would you be most likely to use a loopback plug? And I've got some different options there for you to look at. Is it to test end-to-end WAN connectivity? Does it validate the operation of physical router interfaces? Does it troubleshoot routing tables? Is it used to configure VLANs, or does it block all outbound file transfers? What would a loopback plug be used for? This is one of those things that from a loopback perspective, you need to know these things in the networking world. There will be times when this loopback plug will be very useful. In fact, it's one of these times where usually it's sitting there waiting for you to use it. And when you're ready to use it, you can't find it. It's one of the hardest things about a loopback plug. It's a physical plug. So if it's a physical plug, well, how could I use this? Would it be used to those things? Test end-to-end WAN connectivity, validate operation. Again, no answering in the chat room. And if you're just joining us, we are answering these questions on the Socrative site, Socrative.com. Click the student login and go to the room name Professor Messer. So let's look to see what the answers are. You know, when I put these questions together, I'm trying to think of questions that are going to fool us. And it's not to be mean. It's really because if you don't know something or you get something wrong, or in my case, you break something, whenever you go through the process of learning it or fixing it or understanding what you got wrong, you're learning something. So I'm hoping that I'm at least hitting some of those as we go through this today. Let's see the results. Are we testing end-to-end WAN connectivity? 35% of you said yes, we are. Are we validating the operation of physical router interfaces? 50% of you said yeah, you're testing physical router interfaces. 6% of you said troubleshooting routing tables, and 6% of you said block all outbound file transfers. Nobody said configure VLANs. I guess people have configured VLANs before. You know, that's not what you would do with that piece. So what is a loopback plug used for? Well, it's used to test physical ports themselves. And I also mentioned in my presentation here that you can also fool your applications as well. And some applications with older operating systems needed the network ports to be up and running. And in fact, a number of routers and switches and even firewalls these days will do certain things if the port is active, and you can plug a loopback plug in to make it come active, to fool the device into thinking that that particular interface is active. There are all kinds of loopback plugs. There are serial loopback plugs. You don't see these used much anymore, but for WAN connections that are serial based, it might be, I didn't mention here a V.35 loopback, but there could be RS-232, there could be serial. There's certainly T1 loopback and fiber type loopback. One important thing to consider, let's go back. You're gonna have to see this piece, is that loopback plugs themselves, they sound like it's a crossover cable, but it's not a crossover cable. These are different types of plugs. In fact, whether you're thinking of serial or Ethernet or T1 or fiber connections, they're all different kinds of loopback plugs. And if you just go to Google, this is what I like to do, go to Google, you type loopback plug, you click the image link on there to search for it, you'll see tons of images of loopback plugs. They're all a little bit different. So this is one of those things that when you need it, you need it. And usually you're trying to troubleshoot some hardware. So this is how a loopback plug would be used. I'm working on a router. It's over a WAN connection. And I notice in the router that the statistics in this device are incrementing errors. It's just constantly saying every once in a while I'll get errors on the line. It says that traffic has come in to this port and it's not in a good shape. It's been corrupted in some way. This is not a valid frame. This information I'm throwing onto the floor, they're going to have to send that again because I can't make heads or tails of this. So what you'll do, of course, is you'll call your WAN provider and you'll tell your WAN provider, I've got a problem here. I'm seeing errors, but now you have to figure out where it is. Is the error in the physical port of the router? Is it in the cable between the router and the CSU DSU? Is it between the CSU DSU and what we call the DMARC, the mark of demarcation in your data center? That's the box that the telco provider, the WAN provider, puts on the wall. And is it that cable that goes from the CSU DSU to the DMARC? And then, of course, from the DMARC, it's all belonging to the telco. And what the telco will do will say, well, I don't know, maybe the problem's on our end. Maybe there's a squirrel outside that is gnawed through some of that cable. Let me send a message down to my DMARC, and I'm going to put it into a loopback mode in software, which effectively gives the provider a way to send traffic all the way to the DMARC. It turns around right in the DMARC. It never even gets into your equipment, and it goes right back to the telco again. And what they'll do is send some very specific streams of test data down, and they'll see if they receive exactly the same data on the other side. This is called a loopback test. And that way they can say, no, the problem, at least on our side, we're good. I'm talking all the way to DMARC and all the way back. And so now you as the network administrator has to now start swapping things out. And in the case of the router, how do you test to see if the router port is sending information properly, or the server port, or the port on this device you're using? You would use a loopback plug to plug it into that connection. And usually these routers and other devices also have a loopback test inside of them where they'll run their own set of data through. It'll go out the loopback plug and right back in again. And if you're sending and receiving the same thing, you can at least to some degree feel a little better about that particular interface working the way you would expect. This is one of the things you always have to go through when you're troubleshooting and making these things happen. You have to run these tests over and over and over again. So for those of you, the 56% who said validate the operation of physical router interfaces, you would be absolutely correct. I'm sorry, folks, that said test end-to-end WAN connectivity. I guess to some degree it could be used for that, but that's a very specific case, and you're not really testing end-to-end WAN connectivity. You're really testing everything that goes in and goes out of one interface. So kind of a curveball I threw on you there. You have to read these questions very carefully, read the answers very carefully, make sure you parse the entire question and the entire answer so that you don't read test connectivity. Yes, it's used to test it doesn't actually test any connectivity when you start thinking about loopbacks. So let's throw another question at you. This is going swimmingly, isn't it? So let's try another one. Let's try this one, which is, on which of these networks would you be most likely to use CSMACA? CSMACA. And I've got different options for you. There's 10BASE-2 Ethernet. There's 802.11g Ethernet. There's 10BASE-T Ethernet. There's gigabit Ethernet over fiber. There's a lot of Ethernets and fibers and things going on here. But only one of them would really be used with CSMACA. So this is one of those things that I like to do with these questions is I like to make these questions two-step questions. First, you have to know what CSMACA is. And then at that point, you would have to know how it's applied, where you would use it, what networks use this CSMACA. It's used, of course, in alphabet soup. That's where you would use it. To answer, of course, you go to the Socrative.com, go to the student login. You've got it by now. All of you are answering these questions by now. You can put in any name for the student and you can use the room name, Professor Messer. And you'll be taken to that page and it'll just keep giving you answer over and over and over again. Again, no answering in the chat room. And certainly for those of you that know it, I think there are plenty of us that are still learning it. So one of those things that is a challenge with networking is there's so much to the networking field. So this is a question that really focuses on how the network operates at kind of a lower level, at kind of that layer 1, layer 2 functionality of the OSI model. So let's see how we did. Of the folks that have answered this, we've got 33 of 30, 35 of 57. Nobody has said 10BASE-2 Ethernet. Most of you are saying, what in the world is 10BASE-2 Ethernet? Well, in this particular case, that would be Ethernet over coax, so it's not the baseband connectivity. It's what that is. 802.11g Ethernet, that would obviously be a wired or Wi-Fi Ethernet type functionality, 52% of you. And then we're kind of split here, 10BASE-T Ethernet, 20%, and gigabit Ethernet over fiber, 22%. So we've got a few differences here to pull from. So let's break down this word first, the CSMACA. See what in the world this thing is. And if we look at it, the last two letters, CA, stand for collision avoidance. And already you can sort of see what the answer might have been on this particular question, because this is what you would commonly use, not always used on wireless networks, but it's common if you're going to see it, it's going to be on a wireless network that you would see it. That is because a wireless network doesn't have the luxury of a wired network. On a wired network, whenever you're sending information out of an Ethernet, physical Ethernet wired interface, you don't hear what you're sending on the receive. There's separate pins, there's separate copper cables for the send and for the receive. So when you're sending information, you can still listen on the copper side. Well, with wireless, you don't have that. With wireless, it's a radio station. And as you're broadcasting your radio information, you're also effectively overloading your receiver on this device. It's sort of like if you've got you've got a megaphone that you're sending information out of, and there's speakers right here that are repeating everything that you're saying into that megaphone. If somebody did say something down there, you'd never be able to hear what they were saying. So that's a little bit of a problem on a wireless network. You could send a lot of information, but did it get to the other side? Did somebody else talk at the same time? How could you possibly avoid this collision? You avoid it using CSMACA. This is common to see if the wireless network or whatever you're using has been set up. We did this with modems back in the day. You certainly see it on wide area networks often, is the ready to send and clear to send signals. So what you're doing is setting up kind of a way for everybody to participate together so that, hey guys, I'm ready to send some information. And then there would be devices on the network said, okay, you are clear to send. Everybody be quiet. James is going to say something. Okay, James, you may speak now. And in that way, you're avoiding any collisions out here on the network. This also solves a problem with wireless networks when the device that is on the far side can't hear the device that is on the other far side because there's an access point in the middle. Both devices can talk to and hear the access point, but they can't hear each other. So how in the world would both sides know when to talk? Well, they talk to the access point and say, hey, I'm ready to send. And the access point tells everybody, okay, everybody be quiet. The guy over here, even though you can't hear him, he's clear to send. You go and do that. And that's why we call that collision avoidance. So we can make sure that we avoid any examples or any circumstances where two devices may be communicating at the same time. Very, very useful to have that capability there. And it means if we go to the question that was asked, this is on wireless. So the 59% of you that said 802.11g Ethernet, absolutely correct. You got that one right. All right, let's go to another question in the chat room. Make sure we've got that there. Do not answer in the chat room, but the answer that we have here is very similar to, well, we'll stick on the networking side of things with cabling and those types of things. Which of these would commonly use an MTRJ connector? A lot of buttons I'm pushing on my screen here to get all this up. Would I use MTRJ on frame relay, gigabit Ethernet, T1 WAN, broadband Ethernet? One of these is going to use an MTRJ connector. Again, one of those things where I like to give you a couple of different steps. First, you have to know what MTRJ is, and then you have to know how it's applied. Very useful for the Network Plus certification. If you're trying to figure out all of these things on a Network Plus perspective, you're trying to know exactly what you need to know. Of course, there are an entire list of exam objectives, and that's really where I go to when you ask these questions and when you're registering for this, and I'm putting them into this mode of questions and answers. I'm going through that list as well and making sure that the things I'm asking you are really coming from the exam objectives. So you can be assured if you're watching this live or you're watching the replay and you're wondering, am I going to need to know that for the exam? That's the question every student wants to know. Do I need to know this for the exam? Yes, you do need to know this for the exam. That's an important consideration. So of course you can go to Socrative.com, Socrative.com. I will get this right eventually. I promised last week that I'd figure out how to say it, and I did. Now, of course, I'm not saying it right. And go to the Professor Messer room, go to Professor Messer, and answer that one. So let's see what our results are of this. And again, I'm throwing things out at you maybe you haven't heard before, because 22% said frame relay, 39% said gigabit Ethernet, 26% said T1 WAN, and 12% so far broadband Ethernet. So what is this MTRJ? Well, it's a fiber connection type. This is one of the challenges you will have when you get into a data center. Usually it's a data center or a comm room or a place where you have fiber runs. Any place you have fiber, you're going to run into a challenge because you have to know exactly the type of connector you're going to use on the end of the fiber, because there's 4 or 5 different connector types that you could possibly see today when you walk into a data center. This is just one of them. This is the MTRJ. Mechanical Transfer Registered Jack. You could also see this referred to as Media Termination Recommended Jack. Can we make this harder on ourselves with all these crazy names? The important part of this particular kind, and it's kind of hard to see here, but both of the fiber strands are inside of this. It's a small type of connector. It's designed to be very tiny, not very tiny, but certainly smaller than the other, relatively speaking. To the other fiber connectors, it's one of the smallest. And when you're working with these very large and high density switches and routers, you can have a switch that can have 100 ports, more than 100, 144, over 200 ports on a single physical chassis. And to be able to get the amount of density we need for all of these devices that are connecting, we need to fit as many ports as possible. So there's a real estate problem. We have only so much room in a chassis. It fits in a 19-inch rack. So you've got 19 inches. To make it bigger, you can only go taller and smaller. That's all you can do. Is go vertically and not horizontally, because your horizontal is stuck to 19 inches. So in that particular case, if you got smaller ports, I can fit more interfaces onto a single slot in this chassis. So the manufacturers love these tiny interfaces so they can plug these in. Well, fiber, the traditional fiber interfaces tend to be kind of big, and you're plugging it in. Some of them even larger, are taking up more room than a standard Ethernet copper cable. So that's one of those that really does really come into play when you're in a data center. So if you're working with fiber and somebody says, we need a fiber patch, we need to go from that switch over there to that patch panel over here, can you go grab a fiber patch that will do that? And your first question should be, what type of connectors are on each side of this? Because the fiber that you will need will have, maybe it's MTRJ on one side and SC on the other. But you won't know that until you go check those. And then, of course, you have to make sure that both of those sides are the correct fiber type. There's a lot of other things you have to know, but you certainly need to know the MTRJ. And in the chat room, people are saying it needs special tools. Well, very rarely would you be the one creating or building a fiber patch cable. We usually don't create these ourselves. It takes some specialized equipment to be able to put together any type of fiber connector, because you're dealing with light, and if you don't do it correctly and the light is inhibited in any way, if you didn't put that connector on properly, you will lose signal, which means you won't be able to run the fiber as long as you would like. There's some connectors like this that they get smaller, they're harder to make. So there's also that challenge associated with them. Usually you're buying the fiber, it's a certain length, and it goes a certain way. There's some very large organizations that do have people on site that are trained to not only do the cable for you, but also build fiber for you as well. Very unusual to find that, however. And it is much more common. And even I can create my own copper patch cables. Fiber, though, I'm going to leave that to someone else. It takes a lot of time. You have to polish the end of the fiber, and you have to take the polishing and you have to run it in figure 8 patterns over the fiber. Painful. Just painful to be able to do that. So for those of you that didn't answer this question, frame relay, gigabit Ethernet, T1 WAN, broadband Ethernet. If you chose gigabit Ethernet, the 45% of you, absolutely correct. Frame relay generally is brought into a facility over a serial connection. Usually it's T1, although it could be T3, it could be coax. You're running that particular piece. It could be T1 WAN is also generally a copper serial connection. And broadband Ethernet usually brought into a facility also on copper, usually on coax, and therefore you wouldn't be using an MTRJ because MTRJ is for fiber. Okay, this next question is one of the few times on the exam where you may need to do some calculations. Fortunately, the calculations relatively easy. So get your piece of paper and a pencil if you need it, because usually when I do these questions, I do, because I'm asking you what the decimal equivalent is of 1001. And now you have to answer this. Your possible answers are 153, 4, 18, 152, 255. That's also the scores from the game last night. Time for baseball scores: 2-3, 1-0, 4-4. Ended in a tie. I guess that game's in progress. There is a lot that you have to do with binary calculations on the Network Plus exam, especially when it comes to subnetting. You'll be doing subnetting the rest of your life with networking. So not just in IPv4, you're going to be doing a lot of calculations with IPv6. It's important to know how to convert between binary and decimal and back again. So I like to ask these questions. So I didn't ask a subnetting question this month, but I did try to give you a perspective of what a subnetting question might be. So think this one through. And some of you just maybe guessing. There's no penalty, of course, for guessing. We can do that as well. So do what you have to do to make that calculation. No cheating. Don't bring up your calculator. Don't bring up your decimal octal binary conversion calculator. That's cheating. You have to figure it out yourself. Okay. So let's see how we did. We've got a few people that have answered so far, and we've had 50% of you said 153. None of you said 4. We've got 15% that said 18, 13% said 152, and 21% said 255. So what is the answer? What could this possibly be? Well, let's step through it. First, let's step through how you would calculate this and the basics of binary math. So on your piece of paper, I want you to just write down these little green markers. Just start in the far right and put a 1, and then double it. Double 1 is 2. What's double 2? 4. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16, 32. 32 plus 32, 64. 64 plus 64, 128. So if you take each one of those and you put them in their own little column, right? So everything in binary is either a 0 or a 1. So whenever we looked at the number I just gave you, 1001, 1001, there's 8 digits there, and they all fit underneath these green numbers that we wrote down. Usually we do this in sets of 8, which makes it a little easier to be able to work with. This is an octet. This is 8 of them. So you may hear, especially when doing subnetting, that we're talking about the third octet. That's what we're referring to when we say that. So it's useful to have this conversion chart. This is a conversion chart for you that will convert between decimal and binary. So the question we had earlier is, what is binary 1001 in decimal? So first thing you should do is write out 1001 and put right on top of that your conversion chart. This is all you have to do. Simple addition. There's no complexities to this at all. It's one of the things I love about decimal to binary conversions. There is nothing that you would have to do that's very difficult. Now, every place there is a 1, I want you to bring down that number. So there's a 1 under the 128. There's not a 1 under the 64 that gets a 0. There's not a 1 under the 32 that gets a 0. There's a 1 under the 16, bring down the 16. So every place there's a 1, bring down the number from your conversion chart. Every place there is a 0 gets a 0. Okay, that's pretty easy. Now add them all up. So you would add up 128 plus 16 plus 8 plus 1, and the number you get is 153 decimal. And if you go back to looking here, those of you that have done those calculations now, oh yeah, I remember how to do that. 71% said yes, 153. That's exactly what we wanted to be able to do. That's the number you want right there with 153. If you ever need to take and convert back, or you're trying to figure out what number is 153 in binary, you simply reverse the process. You take all of your numbers, and there's only going to be a certain set of ones and zeros that comes up with that piece. So in the videos on doing this binary math, I take you through both of those. So you see the thought idea and the process of stepping through each one of those and understanding what to do with those pieces. If you are watching this video for CE credit, you want to be able to get an extra hour of CEs behind you, you can participate in that. I'll send you a little email certification that says, yes, I saw this. If you go to the top of the Professor Messer website and click on the Contact Us link, and send me your email. Inside of that, I'll ask for your email, and you will send me the code or the special phrase of binary conversion. So send binary conversion to me, and I will send you a certificate to be able to do that. Very useful to have that there. Also, as a point, we'll take a quick moment to thank our friends at GTS Learning. They're the folks that I partner with. If you've ever seen their books, my videos are in their books. They're not only in their digital ebooks that you can find, but they have in their printed books a QR code that you can click on that pops up my video that plays to go along with the content in their book. It's a great way to combine both my videos and the book. And it really is a nice partnership. And they're great folks. I like working with them, and I like their training materials. They have, for the Network Plus certification, these live labs that you can work with. And one of the things I like about the labs is it allows me now to do some of these practical applications of what you're learning. This is the biggest issue, of course, when we're talking about the newest CompTIA exams, is that it requires you to not only know the answers for the multiple choice section, but they have what they call performance-based questions. These performance-based questions could be fill in the blanks. They could be putting things in a certain order. It could be listing out the slowest to fastest of a certain network type. It could be a simulation. They could put up a command line and expect you to perform a certain type of command. This is one of the things that is useful if you have all of these things already on your computer ready to go. But if you'd like to set up your own lab and you'd like to have a machine capturing packets and have an Active Directory server and be able to do some Windows transfers between those and capture the information and see what's going on, well, it becomes a little bit more of a challenge to do something like that. Well, with the GTS Learning Labs, we do all of this in real time. In fact, I've got the GTS Learning Labs up right now. Here's a section for the Network Plus on configuring DHCP servers and clients. I'm going to start that one by clicking on the name. And what this brings up, you can see on the left side, are all these virtual devices, a server, a client, a gateway, a router, and a window or a device running LAMP. So you've got the whole web server package there to be able to run everything all at one time. Let's start these up to get these running. So you've got the Linux, and you've got the Apache, and you've got the PHP, you've got the database, all running on that one device. It's effectively the same thing I'm running on my Professor Messer Windows server, or my web server. It's not running Windows, running Linux. This is also a nice front end because it gives you the labs on one side. You can see how the lab's laid out, and you can pop that out and look even further, and I can even step through the lab, and it tells you with screenshots exactly what you should be doing in the lab. As these devices start up, I can then connect to them, and this is all done virtually. Someone last week was saying, well, gosh, isn't there a lag at being able to do that? You're running effectively a remote desktop into not just a virtual environment. This is a real lab. This is not one of those packages you buy that's all self-contained that pretends to be a Windows front end, which is really what the exam does for you. This is really running Windows. It's really running Wireshark. It's an actual operating system. So you didn't have to go out and buy any of the operating system things either. I don't think the gateway, it does have some credentials I can log into. So there's the connection. It's running Windows Server, and there I'm connected. I'll just start some things up so you can get a feel for it. Look how fast that is. There's no lag here. That's very nice. So let's start a capture up here. We're running Wireshark. Let's just start with whatever the defaults. Oh, we don't have anything set for default. So let's start it up. Let's choose an interface. That's a good one. Start the packet capture, and we'll start grabbing packets from the internet, from the network connection. At the same time, I'll start up a server. Here's a server, and so I can now run through configuring a DHCP server. We can capture the DHCP packets. We can understand now the DHCP process when it has some offers, and it acknowledges the offers, and then you finally get an IP address. You can see all of that happening, all from this device. Great virtual system to be able to do this, and the folks at GTS Learning have got a special price on it. If you go through my link, if you go to the GTS Learning site itself, it actually costs more. But if you go to professormesser.com/netlabs, you'll get a special price on these labs, $99 for a whole year. Now, if you think maybe I'm not going to use this, you can use this lab free for an hour. You can sign up right now, and for an entire hour, you've got access to the lab. So it gives you an opportunity to try it out, see if it's for you, see if it's something you're going to want to use, and then at least you've you've now stepped through it and you understand, yeah, this is for me, or maybe not. At least we tried it for an hour and we're in good shape and we've at least given it a shot. So that's one of those times where it can really work out for you to try it out and see if it's there. And you might even find that you didn't even have to build your own lab in your house. It's all sitting here for you, all ready to go on the live labs. And we want to thank GTS Learning for helping to support our live streams and to make all of this available, and especially for their pricing. There's our great folks over at GTS Learning. And we want to thank them very much. Back to our questions. Get ready. If you have not logged in to the Socrative, I got it right that time, link, then you can log in and go to the room named Professor Messer. The next question I have for you is relating to routing. So which of these is a link state routing protocol? Which of them is a link state routing protocol? There is OSPF, there's RIP, there's BGP, there's RIP version 2. Which one of these is a link state routing protocol? Link state routing protocol. So again, another two-step process. You have to know what link state is, and then you have to know how the protocols work, and then you'll be able to get this one right. So we got a few folks that are responding now. This is one of the nice things I like about the Socrative method here that we have, this website, is that I give you the answers, or I give you the questions immediately, and they pop up immediately on your screen or on your mobile device. You don't have to wait for the stream to catch up to you, which is kind of nice too, to have that there. It's one of those nice pieces. So let's see how we're doing with this. With the don't answer in the chat room. No fair to answer in the chat room with those pieces. Let's see what we're doing here. You can see that 75% of you said, oh, it's clearly OSPF. 13% of you said, no, it's RIP. Another 16% of you said, no, it's BGP. And nobody said RIP v2, which is interesting. You'd think that RIP would be, but not RIP v2. Shouldn't they both be? Are they the same thing? What's the difference? Well, you're going to have to find that one out on your own, because we're going to focus instead on just link state routing at the moment. Oh, we're not. Let's actually describe the two different methods. Really, there's three you'll run into, but you'll certainly run into two major kinds. One is called distance vector routing protocols. And distance vector routing protocols determine how to get to another location based on how far away it is. This is the distance to this. And the distance is usually determined based on number of hops. How many routers have I got to go through to get to that site? Well, if it takes 7 routers, 7 hops to get to that site, and it takes 2 hops to get to this site, I'm going to go the way where it's closer. The distance is smaller. And of course, your distant metrics could be other things as well. But generally, with these types of protocols, it's something like distance vectors, usually using hops. So that's how we determine which way to go. What vector should I go? We go the shortest distance, and that's why we call them distance vector. This is something that's done with most of these dynamic routing protocols. You don't really have to do anything. You effectively turn the routing protocol on. There may be some minor configurations you have to do on the routing protocol configuration itself, but you don't put in any routes yourself with these types of protocols. This isn't like static routing where you have to tell every routing device how to get to every other network. You can imagine on a network with many routers across many locations around the world, that can be tedious. And every time you add a new network, you got to go back to every other router and add that network link into the routing table. That would be ponderous. That's why these dynamic routing protocols are so useful. We just turn on the routing protocol, all the routers talk to each other. Hey, how you doing? Oh, hey, how are you? Well, tell me what routes you know about. Well, here's the ones I know about. Tell me the ones you know about. And then everybody shares their information, and they now know how to get from place to place without you having to type anything in. And they work just like that. They have a conversation. Did you see the game last night? I sure did. This is really great types of protocols on the distance vector side to use if you have a relatively small network, and you could immediately... You could probably have seen a problem with this scenario. If you got 3 hops to go one place and 2 hops to go to the other, distance vector is going to go the 2 hops. But what if those 2 hops are over barbed wire and the other 3 hops are running over 100 megabit Ethernet? Well, the 3 hops would actually have been better. So this isn't the best possible scenario with this distance vector. Distance by itself is probably not the sole metric you should use to determine what routes you are going. But some of the things that you will find using distance vector are RIP version 2, and BGP. Those are, generally speaking, distance vector routing protocols. So there's another type of routing protocol that uses link state. And link state is, at its most basic level, is if there's a link or a connection to that location, we will take it. If the link is not there, then we won't take it. It recognizes where these links are and what they're doing. It also considers other metrics as well, things like the speed of the link. So in the scenario we were talking about earlier, where it was 2 hops over barbed wire or 3 hops over 100 megabit Ethernet, well, now with these types of routing protocols, they can possibly take advantage of some of those types of metrics as well. This means that I could use a lot of different scenarios. I can scale it very well. It's something that I can use in a very large network. And usually it's OSPF. It's a very good example of this. ISIS is one that is used by, usually it's over on the service provider side. You don't generally see that in the corporate or enterprise world. Usually see OSPF being used mostly in the enterprise world to have this connection and use this dynamic routing to these remote locations. Very useful to have there. So for those of you that said OSPF, the 66% of you that said link state, yep, that's OSPF. You are absolutely correct in that case. Again, get that nice star for your link state routing protocol. All right, let's do another one. We're doing well here on time. For those of you that have called in, the phone number, of course, is on professormesser.com/live. I will be taking calls after we get through all of these questions this first hour or so. So make sure you make a note of that. But in the meantime, I have more questions for you. And the question is, which of these protocols is used to automate the configuration of DNS settings? You got a few options here. Automate the configuration of DNS settings. You would use RIP, you would use bind, you would use OSPF, you would use DHCP, you would use TFTP. I have many different options there for you to choose from. Again, no chatting about the answers with those, I guess, until we finally get the answer out there. In the meantime, it's a secret. In the meantime, don't tell anybody at all what the answer is. And I can see you're already answering those questions in there. One of the things that you'll be working a lot with in the networking infrastructure is automation. Whether it's automating the backups from your routers, automating addressing information, automating how things work on the network side of things, automation's great. And so it's important to understand a lot of these automating functions and protocols so that you will not be thrown by them when you first see them. And the question asking, configuration settings on a client or a server? How about both? This is used to just generically speaking to automate the configuration of DNS settings. It's a very sort of, I won't say it's a vague question. It's a very specific question on what I'm saying here. Don't read too much into it. That's an important consideration with these exam questions, is you have to look at every question as its own little world. So not only do you have a question here, don't get hung up on the question. You should read the answers to help give you context to what the question is asking, because the question is spot on. I spend some time when I write these questions, I read them, I try to interpret them a certain way. These are all my questions. I write them before we have these events. So I'm not grabbing them from somewhere else. And I sit here and I change the questions around quite a bit before I finally give them to you. So that's one of those things that is important to consider whenever you're working with those. So let's see. Yes, once I show the response, you can absolutely talk about it, because I'm going to talk about it. And the responses so far shows that 2% said RIP, 24% said bind, 2% said OSPF, 67% said DHCP, and 5% said TFTP. I think we have at least a lot of people that have said, well, it's DHCP. Usually we think about DHCP not as DNS settings, but as IP addressing. So something here is not quite right with our thought process. So let's look at what these types of automated protocols do. And the automated protocol we're going to talk about is DHCP. DHCP, we think about as giving people IP addressing, but the DHCP process can configure automatically many different configuration settings on your devices, not just the IP address, subnet mask, and default gateway. It can configure DNS settings, TFTP servers, put settings inside of your device. If this device is a telephone, a voice over IP device, that voice over IP telephone will get voice over IP specific configuration parameters. So DHCP, very powerful. It can send down the wire quite a number of different things. In a voice over IP case, those are called DHCP options that are sent through on there. This is a very old protocol. It's been around for a while. It started as a protocol called BootP for the Bootstrap protocol. BootP, though, was great for its time, but it didn't include a lot of the things that we need on our more modern operating systems. So it also didn't keep track of when IP addresses were made available again. So we needed some way not only to give the addresses, but also to free the addresses up. That's why we created the Dynamic Host Configuration Protocol, or DHCP. Came out in 97. Back in the 1900s, we were running DHCP. It's been around for that long. It's been working great. DHCP is a great protocol, and we've made changes. For instance, voice over IP, not something we were doing a lot of in 1997, but as the voice over IP technologies were there, we added other capabilities to DHCP to do things like DHCP options. A great set of protocols. They run swimmingly. A very simple process, really. You've got a client workstation down here that needs an IP address, and it's going to send a discover command. Again, it doesn't have an IP address, so it sends a message out across the network as a broadcast, and it can even hop through routers if you've told your router to also be a DHCP forwarder. Normally, broadcasts don't go through routers, but you can tell some routers that, by the way, if you see a DHCP broadcast, send that one on through. And in fact, that's what we did in this picture. And once the DHCP servers, in this case, multiple DHCP servers, see that information, they send a response back, an offer back, again, over the broadcast that says, okay, well, here's some options for you that you might like from a DHCP perspective. Grab one of those. Grab one of those IP addresses and see what you like. And again, it passed through that router. Now, the DHCP server is way down here. How did the DHCP server know that it came from that particular subnet? Well, there's settings that you configure on the router whenever it's forwarding that it's going to forward it from a particular interface. Therefore, the DHCP server knows where that came from. There's some other ways to do that as well. We aren't going to go into the specifics of that. There's some information you can put in the packets themselves to show that information. So the client workstation says, that's great. I'm going to take this particular response. Of course, this broadcast would go everywhere, but the only one this was directed to was this original DHCP server on the local subnet. And at that point, the DHCP server says, great, you're the big winner. You can keep that IP address. I acknowledge, in fact, that you are now the owner of that IP, and there you go. We're in good shape. So for those of you, before I put that question up, those of you that answered DHCP as number D, letter D, symbol D, you would be absolutely correct. Oh, we're doing stuff now. I got another one for you. I kind of popped it up there on the screen really quick. Which one of these would be the best choice for troubleshooting an MTU? Are you down with MTU? Then you should know the best choice for troubleshooting the MTU. I've got some options for you. Would you use, if you were just sitting down, you're having a problem understanding if the MTU was right, trying to be vague here. Would I use ping? Would I use route? Would I use traceroute? Or would I use netstat to troubleshoot this? Which would I try? The first thing I would do, how could I test the MTU? How could I determine what the MTU was? How's that for some examples of things you should try to figure out based on the vague nature of my attempt to give you a hint. So would I use ping, route, traceroute, or netstat to be able to test an MTU? MTU. What is an MTU? What is that? I don't know. And that's where you would need to find out. So we'll go to the Socrative.com, go to Professor Messer's The Room Name, and answer what you think it would be. I love it when this happens. We've got like a horse race. It is right there. A lot of you said ping. No, it's traceroute. No, it's netstat. On my screen, I've been watching it go back and forth with different devices. Oh, no, this one's winning. Now this one's winning. Now that one's winning. Now that one's winning. Those pieces going back and forth. What would be the best choice for troubleshooting this MTU? MTU. Is it something that's empty? It's nothing. No, it's not empty. It's not MTU. It's MTU. Mike Tango Uniform. The MTUs. This is one that you admittedly would rarely have to do. But it is a troubleshooting process that can absolutely help you whenever you're trying to fix this particular kind of issue. It is this is something that generally you run into when you're working most generally with VPNs, especially IPsec type VPNs, but it can be really on any network. You might have to deal with MTUs, especially if the network topologies are changing as it goes through the connection. It's not Ethernet all the way through. It's a tunnel, or it goes from Ethernet to a WAN back to Ethernet. And the maximum transmission unit, the maximum size of the data that you would put through the network can be an issue if you're ever sending traffic from one side to the other. Because if something is too big to get through a pipe, especially if you go through a tunneled connection, you may be sending full-size Ethernet frames. When you get to the tunnel can't take your full-size Ethernet frames because it has to tunnel them. It has to wrap itself around it, and now your frame's too big. So it has to tell, as you're starting this conversation, I can only accept this maximum transmission size to go through this tunnel. So if you're sending something to me and you don't want to fragment it, I mean, because Ethernet's great, TCP/IP is great. It'll break it up into tinier pieces and send the fragments through, but that usually comes at the cost of efficiency. It slows down the amount of traffic we can get through those particular links. If you want to maximize the efficiency, then you want to stick to what the maximum transmission unit is for the entire path all the way through. So when you get into those scenarios, then you want to be able to really understand the traffic that's going through. The problem you have with these types of scenarios is certain applications will send traffic, but there's a bit inside of your IP packet that says, don't fragment this data. So if you're sending a full-size Ethernet frame, you've set the bit that said, don't fragment the data. It gets to the tunnel, and the tunnel says, I've got to fragment this to get it through, but you've said, don't fragment. I'll throw you on the ground. Happy birthday to you, because now you can't get through. That's it. No way you're going to get that traffic through. We've got a stalemate. You've said don't fragment it, but I've got to fragment it to get it through. Therefore, it doesn't go anywhere. I dropped it on the ground. Usually, it actually sends a message back via ICMP that says you just sent me something that was a fragment that said don't fragment, and I couldn't send it. So I'm sending you a message back via ICMP that says sorry, this didn't work. You know, we often think of ICMP as ping. ICMP can do many, many different things. And this is just one example of one of the things that ICMP can do for hopefully the link between you and that device that's dropping your packet doesn't filter ICMP messages. We do that a lot on our enterprise networks. And yet again, another challenge of troubleshooting this. So the key then would be to understand between my machine and the one that's on the destination of where I want to go, how big of a packet can I send if I'm sending it with a don't fragment bit set? So a great tool to use for this is ping. Ping can send not only, hi, are you there, and get a response back. It can send, hi, are you there, please send me a response, and put a certain amount of data, just randomized data within the packet itself. And you can specify what the size of that is, and you could tell it, don't fragment. So you can send this out and just try full size. Can I send a full size 1500 bytes out, send it through? Well, maximum size 1472 once you have all the headers in place. 1472, can it get through? Ooh, it can't get through. I didn't get a response. I didn't get a ping. Let's take it down to 1,000. Let's take it down to 500. So you can now do your own tests. What is the maximum amount of information that I could squeeze out this connection to the other side and still get a response back from the other side? Use the ping command. And if you answered, the 36% of you that said ping were absolutely correct. Route command would tell you the route that information was taking, but it tells you nothing about the maximum size of the transmission unit that can be sent. Trace route will tell you again all of the hops between one side and the other, but again, we don't know the maximum size of the data being sent. And netstat doesn't give you any of that information either. It's very focused on your machine. Netstat's a great utility, tells you a ton of different things, tells you what executables have ports open on your device. It tells you who's communicating into your machine right now, machines you're communicating to. It doesn't tell you anything about the MTU, at least not the way we are using it in this particular case of troubleshooting. If you're troubleshooting the MTU, first thing you do, go to the ping. And that can really help you. Okay. Coming up on, is this our last question? Not quite yet. We're past an hour. I realize that. But I got lots of questions here. So here's another one for you. What's the minimum category of cable that can support 1 gig Ethernet? This is one of those things I think would be a good performance-based question. Is they give you a bunch of categories of Ethernet. I don't know, so I haven't taken this version of the Network Plus. And really, I'm holding back taking this version for this very reason. So I like to think about what different options might be given. This might even be a question on the exam. I don't know because I haven't taken the exam. But I can have a list of all the categories, and I can have a list of different Ethernet standards, and I could say match the minimum category of cable for these Ethernet standards, and I would have to map those things out. That would be a great performance-based question. So we sometimes worry about these performance-based questions as being something we have to have a separate study materials for, but really it's the same material you've been studying with this whole time. Don't let it throw you a bit on this. The options you have for this category of cable are category 3, category 5, 5E, 6, and 6A. Ooh, it's a lot there to choose from. Quite a few options there to have available. In fact, I just threw up every category. So I want to see, do you know what category for 1 gig Ethernet? It's got to be one of these. Which is it? In this case, I think there are a number of you that have indeed done this before. You've done some cabling. And I say this because we got a lot of people responding. Nobody put 6A. Very few people put 6. Very few people put 3. This is absolutely a mean. You know, how many standard deviations is this off, from the mean? Category 5E right in the middle. 68% of you said, yeah, it's 5E. But is it really? Do you really know what the categories are for this? These categories are started with category 3, of course. We started really using twisted pair. Category 3 was one of the first ones we put in. We're running 4 megabit Ethernet or 4 megabit token ring. We're running 10 megabit Ethernet, and we were running a lot of Cat 3. We very quickly upgraded from Cat 3 though to Cat 5. One of those things that we were working with at Cat 5 allowed us to support the 100 megabit Ethernet, which was great. If you're running 100 meg Ethernet, that used to be it. It used to be the standard for everybody. These days, everybody's connecting via gig. And for gig, you need category 5E. This is one of those times, if you're trying to answer that question, category 5E is the one that supports 1 gig Ethernet. In fact, all of you said category 5E. 63% of you said absolutely it was category 5E. You would have been correct. If you were trying to do something with 10 gig Ethernet, at least over short distances, you would use category 6. Usually when you're doing longer than category 6, with category 6A does 100 meters with 10 gig Ethernet. So in my scenario, I'm doing a lot more 10 gig with what I'm doing of transferring things between my NAS and some of my other systems. I like to get the speed that I need. In here, I could probably use category 6 because I don't have a long distance to go in the facility that I'm in here. But if I need to go longer distances, I would do category 6. So that, some nice capabilities there. So another question for you. Here's another one to throw up. I think we've got, this is my last question for you that I'll throw up on the screen here, which is, does it go to the next one? Did I click the next one? Uh-oh, it's not going the next one. See, it's not there. I got another, it says my quiz is in process, but it doesn't look like it is in process. Let's see. So which of these is not typically determined with a multimeter? And if I had a way to go to the next question here, I would do that. I wonder if I have a next question there. Wonder if I put it in here or not. I know I did. There's a couple that I put in here. Let's go to my dashboard and manage my quizzes. Let's see if we can get this one to show on the screen. If not, I will probably popped out of where you were. I'm going to look here and make sure I've got the answers in my list. And I do. Cable, yes. Which of these is not typically determined with a multimeter? Let's see if I can show you this quiz. Let's start a quiz. Let's see if I can get this popped up on your screen. It's probably going to pop through a bunch of options here. Change this. Teacher paste. Multimeters are great. Everybody should have a multimeter. If you don't, you need to get one. Oh, it says I started. Let's go to the quiz in progress. Can it go next? Cannot. It's just not going to do it. That's too bad. I'm going to try something though. Since we're doing this live and since we're trying different things, I'm going to start it all over again and get to that one and see if it works. Because what could that hurt, right? Confirm. So you're going to see this pop through. Don't answer the questions. Let's see, is it going to go next? It's not. So this is probably something on my side that I'm done. So I'm going to give you these questions and you're just going to answer them right now on here. Since I've already got the message up on the screen, you're now going to wonder, what was that? What was the question? So we're going to do the question ourselves. So the question is, we're going to work with these things. Scroll. I'm going to blame these for doing this. So the question is, which of these is not typically determined with a multimeter? Is it near in crosstalk? Is it AC voltage? Is it continuity? Or is it DC voltage? Which one of those is it? And I'm going to try to log on to Socrative. Why do I do that? And see if I could run it in a different browser. See if that will work. Maybe it will. Who knows? Maybe it won't. Probably should have done that to start with. And we'll see if that does. Now the beauty, oh yeah, I'm seeing these pop through now. Here we go. Should have done that. Which of these is generally determined with a multimeter? Click. Boy, I popped through those fast, didn't I? It's okay. We'll take it out of there in post. Don't worry. No one will ever know. Which of these is not typically determined with the multimeter? So we can go to thesocrative.com into the Professor Messer room, and you can answer near and crosstalk, AC voltage, continuity, or DC voltage. One of these. Woo. Got it working. I think that was a Chrome issue. That's the way it usually goes with the browsers. They work great until they don't work anymore, and then you're over it. I'm going to Firefox, which is what I've done. Take that, Chrome, as if Chrome has feelings on this. A multimeter is great to have because you can do almost anything with it, almost anything. There are a few things you can't do with it. One of the things you can't do, didn't fool anybody on the final question, 91% of you, near in crosstalk is a capability that you would typically have on a more advanced cable tester. So that is where you would get that piece there, near in crosstalk. You can absolutely check AC voltage. You can absolutely check continuity. You can absolutely check DC voltage with a multimeter. It's great for checking continuity through a cable. Does this pin connect to this pin? Yes, it does. You can plug it into your wall outlet to see how your AC voltage is. You can check batteries with your DC voltage to see how charged your batteries are. Everyone should have a multimeter. That's one of those things that you should absolutely have around. There's my multimeter right there. Took a picture of it, put it up for you. And you can run all kinds of great things on it. They look very daunting. Multimeters look like they're hard. But in reality, and there's plenty of YouTube videos that show you how to use a multimeter that really step you through all the different things you can do and really get something out of it. So be sure to take advantage of multimeters. They're so valuable and they're not very expensive. They look like they also could be very expensive devices, but the reality is that they're really not that expensive at all. They've got just a few bucks and you're good to go. So for those of you that did answer with that piece right there, you would be absolutely correct on that to be able to do that. There's a number of other things that would be useful to go through with this piece. But we're now at an hour and 15 minutes. I like to keep these things to an hour to have those pieces there and available for you. And certainly there are certain things that information I would like to get from you as well. So one of the questions I have for you, somebody said, we need one more question. Well, you know what? I have one more question for you. And it's this question right here, which is, what topic would you like to cover in the next Network Plus study group? So if you would like some questions or like to cover certain topics, this would be a good place to add it in. Go to the Socrative.com front end. And this one is an answer where you can just type in anything to me. And I've got a big list that I'll pull down after this, and I'll keep those for the next month there to be able to see those pieces. That's that's one of those that can really come in handy for those pieces, is to be able to answer those. And of course, the things that you send in through the week are also, through the month, extremely useful for me as well, to be able to see those things. Great input to have that there. Well, of course, you can always follow what we're doing on the Professor Messer website. We're doing something all the time. Again, if you'd like to know more about my Network Plus study guide, you can find out more at professormesser.com/netsg. Again, subscribing on YouTube does amazing things, more than you will ever know. And of course, I do some things. Mostly it's my A+ pop quiz, but I'm trying to do more things on Twitter and Google+. Just go to professormesser.com and type something in, and you'll get there. You'll get to Google+, you'll get to Facebook, you'll get to all those places. Again, my thanks to GTS Learning for their fantastic live labs. If you go to professormesser.com/netlabs, get not only the live labs, all their book information, and some online tests come with that as well. Some very useful. And of course, I couldn't do all of this, any of this, if I didn't have the support and the emails and the messages and the constant chats that we do on the Professor Messer website all the time. Extremely useful to have that there. I can't thank you enough. And thanks for joining us again. If you're watching this live, we go to the after show and take your phone calls at this point. For those of you that are watching for your continuing education units, you're more than welcome to join us. But if not, we'll see you next time on the Professor Messer Network Plus Study Group. Thanks, everyone.